Hi everyone and welcome back. And in this video we are going to talk about CQRS pattern, which is command query responsibility segregation pattern. Okay, so CQRS is not much popular earlier, but now it is like a common term being used same as event driven design pattern. And we have a lot of use case for using CQRS pattern. From the name itself, it is saying that command query responsibility segregation. It is segregating the responsibility of command and query. What is command? Which is expecting some action to happen. What is query? When you are actually checking or when you want the state of a system to be returned, right? That is query. So it can be divided into two terms. In this video, we will talk about what is CQRS, why we need it and how to use it. Okay. We needed CQRS when we needed to expose strongly consistent data to the services. Strongly consistent data will happen when we are not just executing the random events coming updating the state. No, there will be a one particular responsibility of a command and other we will be just doing query. So it's like a one single gateway to update the system state, and other places we will be just reading it. So one write model and an read model, one is to n. Okay, CQRS doesn't imply working with microservices or a messaging infrastructure or maybe a domain driven design or event driven design. CQRS can be plugged with all these things. You can't just couple it CQRS with the event sourcing or domain driven design. Okay, CQRS design pattern raises the idea of separating writing and reading data from the object to a system level. Okay, in the database tables we can just have a constraint. Okay, you can read this, you can write this, all these things, but it is raising this particular feature to the system level by totally isolating read and write. An application has not only one but two APIs to address it, because one API will be reading it, another API will be writing it. So we are actually segregating the responsibility of read and write to have to maintain highly or strongly consistent data for our system state. Okay, so from the UI you will be making query actions. There is a query model, you will be reading it, and from the UI you will be making commands will be doing a write operations, and there will be a separate set of APIs. This storage may or may not be common. In most of the cases this storage will always be different, because you are making a read and write from two different APIs, two different services, and those services will have a consistent data, because write will happen, then write will project the data to the read, and read will provide the data to the UI. Okay, the read model is responsible for handling and responding to the queries. In this set of videos, I'm talking theoretical. That's true, because here we are just trying to understand the microservice pattern. Once you have a theoretical understanding, then you can convert that into your architecture of your application which you are writing. Okay, let's come back to CQRS. This pattern employs asynchronous message passing that can perform write independently from read. That's true. So you can plug this in with the event driven pattern, where the event can be divided into two parts. One is an action, one is a command, one is a query. Command will perform some action, will update the state. Query will just only read the current state of the system. So write model consumes the command coming from outside, triggering a series of event and update the state in the store. Okay, so there are, like you can say, two different APIs, two different users, two different client. One is writing, one is reading. So write will happen on one particular store, read can happen like 1 is to n, one single place to write and n different places to read. And there will be a projection which will sync the data from the write systems to the read systems. Okay, what are the examples of CQRS? So here we are talking about CQRS and event sourcing, and it is mix of a lot of things. Okay, here we have event store, which is just maintaining the sequence of events. Okay, we have a messaging system, SQS, RabbitMQ, Kafka. You are just publishing this message. So here you can see this is a query endpoint, command endpoint, because we are segregating the query and command. Command will be expecting the change in the system state, so it will raise an event. There is event publisher, publish this event. There will be a consumer, consumer will update the state. Okay. Similarly, once the consumer will update the state, there is a query endpoint which will do a query service. From query model, it will read the data. Okay. So command service will update, query service will read. Similarly here, this is the event source. You raise the event, either command or query, it will go to order service. Okay, it will raise the event to SQS. There will be consumer will update the state, and the query service will read that data and will send to the client. Okay, so this is typically what CQRS is. Here we are actually segregating the responsibility of read and write both. Okay, thanks everyone.